What's up, everyone? This is LeetCode 125, valid palindrome. So, a phrase is a palindrome if, after converting the uppercase letters to lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. Given a string S, return true if it's a palindrome or false otherwise. So, we have an input string here, right? And we only care about letters and numbers. So, for example, we don't care about these empty spaces, these commas, this colon. So when we only account for the letters and numbers, and we convert it to lowercase, we should get something like this. And if we read this forward and backward, it's the same, right? It reads the same forward as it does backwards. So it's a palindrome. So we would return true. Okay, so the way we're going to handle this is we're going to use a left pointer and a right pointer, and we're going to account for whether the specific character is a letter or a number. If it's neither, then we're going to have to move the pointer over, okay? So let's set the left pointer at the start of the string, the right pointer at the end of the string, okay? And we're going to say while left is less than right. Now let's handle the left pointer. So if the left pointer is not alphabetic and the left pointer is not pointing at something that's numeric, then we have to shift the pointer over, right? Because if the character is not a letter and it's not a number, we don't care about it, so we have to shift the pointer over. Now let's handle the right pointer. So we're going to say if the right pointer is not alphabetic and the right pointer is not numeric. And these are built-in Python functions if you are wondering what these functions are on the specific character, okay? So if the right pointer is not alphabetic or numeric, right, if it's not a letter or number, we shift the right pointer to the left, okay? Now, if we enter this else statement, it means that the left pointer and the right pointer are both either letters or numbers, so let's compare them. So when we compare them, we have to convert them to lowercase, okay? So we're going to say if the left pointer is not equal to the right pointer, they both should be lowercase. Return false if they're not equal. Now, I said we can have letters and numbers, right? In terms of what we care about when we compare if the string's a palindrome. Now, if you use .lower, right, on a number, it would give you false. But you need to remember, the numbers that we're comparing are strings, right? They're not like actual integers or floating point values, right? Like if we had a 0 somewhere in this string, right? Like if it started with 0 and ended with 0, when we do left pointer dot lower, right pointer dot lower on a number that's actually a string, it just returns a number, right? So we actually wouldn't get an error or anything like that. So I just want to point that out in case you're confused by that. Okay. So let's so if we don't return false, it means that they're equal. Okay. The left pointer and the right pointer are pointing to two characters that are equal. So if that's the case, let's just move the left pointer over to the right pointer over to the left, right? And basically keep comparing until the left pointer is no longer less than the right pointer. Now, if we exit this while loop, it means that we didn't return false anywhere. So it means that it's a palindrome, right? Because we didn't run into an error where we would return false, okay? So, because again, we only care about letters and numbers. We don't care about any of these other characters that are non-alphanumeric, okay? So yeah, we run our code and it works. Yeah, there's quite a few ways to solve this problem, but I just prefer to write my code like this, using if and else, because I think it's a little bit more readable and easier to understand, especially if you're struggling with these problems, because these problems are fairly easy problems. So if you are having trouble with this problem, you're probably, I mean, there's no point in writing something that works but is a little bit less readable. So yeah, I just write it like this because it's more readable, but there's a few different kind of ways you can approach the problem that ultimately do the same thing. Before I go, I want to show you a solution that you could come up with if for some reason your interviewer was pretty tough and you got this question in an interview setting and they don't let you use built-in functions. You could use the ASCII values to kind of solve this problem. So the way you would do this is you would define a function, right? Call it alphanumeric to check if the character is alphanumeric, right? And basically what we would do is we would return, right? This is basically just going to check, okay, is the character a capital letter, right? So we do something like this. All right, we would say, now let's check the lowercase letters. So we do something like this. Okay. Or if the character is a number, so we'd say something like this, okay? So the way we would do this is we're checking if the character is uppercase, lowercase, or a letter, okay? Now, if that's not the case, we would have a problem, right? So we would call this function now. We would say self dot alphanumeric, and we would pass in this specific character, right? And we would do the same for the right character. Okay, so we could do it like this. Now, meaning we could check if the character is uppercase, lowercase, or a letter using a function like this, using the ASCII values. Now, if you don't remember the ASCII values, I'll show you in a bit. Let me show you this. Let me show you it now. Okay, so here's the ASCII values, right? So we're basically checking to make sure that the ASCII value of the specific character we're at, if it's between these numbers, right, which would, I mean, we're using the actual characters to get the ASCII values, if it's between 0 and 9, or uppercase A, lowercase z, lowercase a, lowercase z. So if it's between any of those, then it's a valid character. Okay, so that's how we check if a number is alphanumeric using ASCII values, okay? Now, if your interviewer is like someone who just hates you and they don't want you to use this lower function to convert an uppercase to a lowercase, you can handle that as well. It's just a lot of work, but I can show you. So let's get the left value. So we're gonna say s of l, right, s of r, okay. All right, we're gonna check, okay. Now, if the left value, right, if the left value is an uppercase, so we're gonna say this, this, and this, okay. I just like my parentheses, so I'm going to do that. Okay, so if the left pointer character is an uppercase letter, we can convert it to lowercase by doing this. Let's convert the character, and we're going to say ord of left, right? And we can just add 32. Okay, now the reason we're adding 32 is because I'm going to show you here. So the difference from the uppercase letter to the lowercase letter that's equivalent is 32 characters, right? 65, so if we add 32 to that, that should be 7, 8, 97. As you can see, 97 is where the lowercase a is. Now, if we have like if we have an F, an uppercase F, if we add 32 to that, that should be 8, 8, 9, 100. Sorry, 32, not 30. 8, 9, 102. 102, lowercase f. See, so we add, so if we have an uppercase letter, we just add 32 to the ASCII value, and we should get the corresponding character in the lowercase representation, right? So that's why we're adding 32. Now you don't want to do something like this, right? Because it would give you the ASCII value. But you want to get the character, not the ASCII value. Okay. So we're going to say that, okay? And we're going to say that. But now we're going to do this for the right character. So we're going to do this. I'm just going to copy and paste it to make it simple, right? So if it's an uppercase, we're just adding 32 to the ASCII value to get it to lowercase if it's an uppercase letter, okay? Now we're going to do if left is not equal to right. We can return false. And if we don't return false, then we can update the pointers. Whoops, I must have forgot something. Let me see. This is where I got it wrong, sorry. I did my A here. It should be lowercase a to lowercase c, not lowercase a to lowercase a. Just a typo. Okay. Now, I know this is super, like, I don't want to say it's complicated, but it's just like, it's just a lot of work, but like if your interviewer really just hates you, they're gonna make you do this. So you might as well learn kind of, you don't have to learn to do this. I mean, it just should be kind of intuitive what you're doing, but yeah, just be aware that you can do this without using any built-in functions. It's just, and I wouldn't really consider getting the ASCII value of a built-in function. But yeah, your interview could make you do this if they really just hate you or make you want to do a lot of work. But I mean, it just depends really on your interviewer. But yeah, just be aware that you can do it like this as well. So yeah. Also, I just want to clarify this in case I wasn't super clear. The reason we have to convert it back to a character is because let's say the left character is an uppercase. If we don't have this here, we're gonna have an ASCII value, right? Not a character. But if the right character was already lowercase, we would have a character, not an ASCII value, because we wouldn't even enter this if. And so we would be comparing an ASCII value to a character. So we just want to make sure we maintain consistency, and that's why we convert back to a character after we add 32 to the ASCII value. And again, you don't remember, if it's an uppercase value, we're adding 32 because it should give us the corresponding lowercase letter. Anyways, I hope this was clear, and I'll see you in the next one. Again, kind of a long solution, but yeah, hope that helped, and I'll see you in the next one.